All right, good morning, everybody. I want to welcome everybody to this Tuesday CEBIT D-Talk event. And I've been asked several times when we say D-Talk, I know it sounds like we're saying detox, but those are two completely different things. So if someone misunderstands you today, you can laugh and say, you meant to say D-Talk. Today is our Digital Transformation Summit. And what we want to do with that is we want to look at how new trends from everything from artificial intelligence to data analytics are being used by companies and at what they're doing with this new technology to enhance the way they do business, but also to enhance the way we live. And we've got a packed schedule today, so we want to get to our first guest. He is the Chief Scientist at Salesforce, Mr. Richard Socher, and he's going to have a presentation, and when he's done, we're going to have a little fireside chat here about what he's doing for a living. So let's give a warm round of applause to Mr. Socher.
Hello, everybody. I'm super excited to be here today, and I want to thank you for coming to my talk. There's a lot going on at CEBIT. Ich freue mich auch sehr, hier wieder zu sein. Ich war das letzte Mal auf der CEBIT vor über 10 Jahren oder so, als kleiner Junge noch. But I'll speak mostly in English since not all of you speak German, so no worries, you can stay. So, I want to talk to you today about artificial intelligence. And why do I think that this is important? Let's see if we can get the slides going. Maybe not. Slides. Thumbs up? Yeah? So, I'll get started anyway. Where are we right now? We're at the beginning, or maybe even in the middle of the 4th Industrial Revolution. And Germany had been doing really well in the first two. We had the steam engine, the invention of electricity, and then in the late 60s, we had computing that was started with mainframes, and now we're at the 4th Industrial Revolution around artificial intelligence. And I believe this one will be even bigger than the internet had been in terms of how much it will change humanity as a whole, the job market, and our lives in general. And the future is already somewhat here, it's just not quite equally distributed. You can already see a lot of AI-driven features coming from some of the largest technology companies in the world who have multi-billion-dollar R&D budgets. Facebook is already doing facial recognition to identify and show you the photos that you're in, tag your friends. We have Amazon giving you product recommendations. You have Waymo and Google working on self-driving cars, and so are some startups, and so are a lot of large German car manufacturers. But unlike them, Tesla has already a car fleet driving around hundreds of thousands of miles. So does Google, collecting a ton of valuable data. And that brings me to the important ingredients of what you need as a company, but even as a government too, and both big companies, small startups, new products, existing product lines, what do you need to make AI successful? And they're basically 3 things: data, algorithms, and an understanding of the workflow of how to infuse AI into standard processes. And the data is the biggest stumbling block for most companies to actually leverage AI. Their data is in different on-prem data sources, some in the cloud, some in this SQL database there, some text files randomly lying around on people's laptops and so on. And you have to first get all your data into a single place in order to even think about getting artificial intelligence to work. And then not only do you need the raw data, but you also need to ideally have some supervision. And I often try to explain this as a simple X to Y mapping. If you have a lot of examples of some input X and some output Y that you want to predict, then you can probably use AI. So let me give a couple of examples of what these X's and Y's are. X could be a German sentence, and Y is a French translation of that sentence. X can be a question from a customer, and Y is the answer that actually answers that question. X can be an image, and Y can be a description of that image. X can be the input of sensors from a car, and Y would be the output actions that you'd have for a self-driving car. So if you can think in your business processes what kinds of examples of such a mapping you you can start thinking about making AI successful. And of course, putting my Salesforce hat on, for anything that's related to customer success, sales, service, marketing, we will do all of that for you and make it as easy as a click of a button. Then the algorithms are fortunately these days often open sourced, but it still requires a lot of work to actually getting them up and running in production with all the complexity of engineering and trust and security and scalability and so on. So in theory, the algorithms are there. In practice, it's still a lot of hard engineering work. And then, of course, the workflows, it's a pretty broad term. You need to carefully think about how you actually empower people and make them more efficient at their job instead of feeling like they're training their replacement when they're using an AI-powered system. So let me give you a couple of examples of what this could be. Here is a large manufacturer of consumer packaged goods, namely Coca-Cola bottles. And there are actually thousands of people in the United States that walk around stores, take pictures of shelves, and then see where is your product actually stored in a shelf. It's a huge manual effort. And instead, we can actually use artificial intelligence. We can have even drones or standard cameras in shelves, take pictures, and then use object detection, classifying and identifying and counting different kinds of objects and images and say there are exactly this many Coke Zero bottles, for instance, and this many Sprite bottles, and all of that. And based on that, you can then automatically come up with new inventory and order new kinds of bottles, for instance. And what's fascinating about AI is that the same algorithm that can be used to count Coca-Cola bottles in supermarket shelves can also be used to count red and white blood cells in images. This is a small startup that counts red and white blood cells and automates tests that used to cost $400 and take 3 days, and basically lowers the price to $1 or $2 and gives you a response of your red and white blood cell count in a matter of minutes instead, changing how pathology is run and improving the lives of leukemia patients and a lot of other folks who are reliant on drugs that mess with your red and white blood cell counts. In general, I think radiology will actually see a vast change in the next couple of years, because radiology is the perfect example where you have an input X and an output Y. You get a new X-ray or CT scan of your head, and out comes a radiology report. A lot of the parts of that workflow can be made much, much more efficient, and in some cases will be able to instill the knowledge of the best radiologists in the world and actually make their knowledge available to countries that might not have as good of a healthcare system as Germany or the United States do. I think we'll see a lot of amazing applications of the merging of different modalities. Here are a couple of research results from my research group at Salesforce Research of what is now possible. Here, the input is an image, and the output is a description of that image. And on the right, you see where the algorithm is paying attention to as it is generating the description of that image. This is a brand new research result. This is not yet in any product, but it is a technology that will allow you to make much better sense of, for instance, your marketing data and visual data on social media. And you can see here a little girl sitting on a bench holding an umbrella is the sentence that is describing that previously unseen image by this algorithm. And this is a pretty incredible change that AI has gone through in the last couple of years. Something like this would not have been possible even just 5 years ago. This is another example of a really fascinating breakthrough that's combining language and visual understanding. Here, the input is an image as well as a question about that image, and the output is the answer about that question. So you can ask, what is the girl holding? Tennis racket. And you can ask lots of different kinds of questions. And once an algorithm has understood and seen many examples of a certain domain, it's actually very, very good at generalizing inside that domain to new images and similar but not exactly the same kinds of questions. So the algorithm had never seen this exact image before. It had never been asked these exact questions for this image before, but it's seen other kinds of pictures about tennis. and then it's able to generalize in that domain. So there's no magic here. If you train this algorithm only on tennis and soccer images, it won't work on Formula One images and say, like, who is winning the race. It wouldn't be able to answer that. But once it's learned enough about a certain domain, you can actually automate an incredible amount. And I think the most interesting manifestation of intelligence is actually language understanding. Connects to thought. It's a pretty interesting, almost philosophical area, but it's also how companies communicate with their customers. So very useful, and there also we've made a huge amount of progress in the last couple of years. Here are 2 example sentences that we can now correctly classify the sentiment of. We can identify if they're positive, negative, or neutral sentences. These are from movie reviews, and it's quite remarkable that we're now able to correctly classify, for instance, the first sentence in its ragged, cheap, and unassuming way, the movie works. This would have been 5, 10 years ago, every algorithm out there would have said, this is probably a negative sentence because it's cheap and ragged, unassuming, negative. Likewise, the second sentence, very easy to fool normal algorithms prior to the revolution that we've seen with deep learning algorithms into thinking that this is a positive sentence. It goes as follows. The best way to hope for any chance of enjoying this film is by lowering your expectations. So there, again, very easy to fool simpler algorithms that just look at words in isolation and don't keep around the context into thinking this is actually a positive sentence when in reality it's negative. So these are just a couple of examples of classification, but we can also now generate language in a way that was impossible before with completely learned algorithms. Here the input X is a long document and the output Y is a summary of that document. And this is the first time we've actually been able to have an algorithm generate multiple coherent sentences based on some input. And this is actually a summary of the blog post that summarized that research paper. And it's quite incredible that this can work in some cases, but again, it doesn't work, it only works in certain domains. And it's trained here on news text, news articles, and so it's able to generate summaries of news articles. Now, where does all of this lead to? There will actually be a pretty substantial change in the job market in the world in the next couple of years. We will see, and this is a great report from McKinsey, even with just current technology, so assuming there's no more progress in AI research, which is of course crazy because there's immense amount of progress in the last couple of years and that will only continue, we'll see that a lot of different kinds of jobs will not get 100% automated. In fact, less than 5% of all kinds of jobs will get 100% automated, but the nature of these jobs will change. The boring, repetitive parts of a lot of our jobs will get automated. And just like 150 years ago or so, over 90% of people worked in agriculture, worked in the fields. Most people now don't really worry about the fact that they're not working hard labor jobs in agriculture. 90% of you are pretty happy that we can be here at CEBIT talking about technology rather than working in the field. But there will be a shift, and you have to continuously educate yourself in this new kind of economy and anticipate both in the senior leadership level of companies, but also for the workers, you have to educate yourself about this change. And maybe just to understand this chart a little bit better, this one highlighted point here is that about 60% of all kinds of occupations or jobs will have at least 30% of their activities be automated. And thinking about what that means is quite different. It's a pretty complex question. In Salesforce, we work in sales, service, and marketing. If in sales you make your sales force 50% more efficient, you sell 50% more of your product, you're not going to fire 50% of your salespeople. You're just happy you doubled your sales. But in service, a lot of companies see it as a cost center, and if you automate 50% of service, you might think about letting go of 50% of your service staff, and you need to think about now in the leadership of these companies what you can do and how you can help those people potentially move into cross and upselling after an algorithm has successfully finished a service case very quickly. And in marketing, we'll actually see new kinds of jobs be created, where you can think about, I could look at every single image on Twitter and find out if my company is mentioned or seen in that image. And if it is, I will retweet this picture if the sentiment is also positive. Or I will create a service case if the sentiment was negative and my company was involved. So new kinds of jobs that allow that kind of thinking will be created in marketing with the power of artificial intelligence. Now, in the long term, I think this will mean that we can automate basically most human basic necessities. Of course, people don't want to just have food and shelter. They want the newest iPad and so on. So that doesn't mean that we'll stop working. But it will mean that, in theory, with the right political system, we could benefit a lot as a society, just like we benefited a lot from automation in agriculture, for instance. And in the end, we will focus more and more on tasks that are creative, that are unique, that are not repetitive, and that require some kind of human empathy that allows us to interact with other people. And lastly, one thing that's very important to realize when it comes to artificial intelligence is that it's only a tool. And it's only as good as the people that use it and the data sets that they get trained with. And so if in your data sets you have certain biases, sexist, racist biases, your algorithms will pick that up and potentially amplify it. So we need to be very careful and think about diversity and equality when it comes to using AI algorithms, and especially in those cases where they touch and change human lives, in medicine, in human resources, and in a lot of other places. And now we'll have a couple of questions. I encourage you all to think of questions too. We'll hopefully be able to open it up to the audience afterwards. Thank you.
Thank you, Richard. Let's see. I wanted to pick up on something that I think you were quoted recently as saying that there is no such thing as innocent data. What did you mean by that?
So in the end, data is often neutral, but how we use it and what we do with it is the important factor. So if your data has certain biases in it, for instance, you're a large supermarket chain and you want to use an AI algorithm to improve your promotion process. Who should run this local supermarket? Now, if you look at just your past training data, a lot fewer women have been promoted to run the supermarket, despite being overly proportioned in the overall population of people who work there. And so you need to account for that kind of bias in your data.
And do you see a willingness to do that?
It highly depends. There are actually a lot of companies who want to do the right thing, who are carefully thinking about this. We also have certain features where we allow companies to literally just drag and drop and create a new kind of classifier, some kind of prediction algorithm. And in those cases, we are thinking about even requiring a learning module that we call Trails or Trailhead to essentially learn about the ethical implications of AI. And we are actually seeing a lot of support of that from many of our customers.
There has been this talk about AI as this possibility of actually improving the human condition, because when humans interact, we do tend to grade and discriminate and give each other value points and minus points, things like that. Do you believe that AI can make us better human beings?
It depends. I think every technology has sort of a dual use scenario where you can use the technology for good, you can use it for bad. There are a couple of startups that actually allow you to chat with a chatbot about your feelings. And we actually see that has sometimes helped people in some serious cases where that one particular startup called Replica, that I'm also an investor in, actually have stories where people were about to commit suicide and then talk to their chatbot. The chatbot asked them about their problems, and they felt for the first time somebody would listen without judgment and so on, and eventually decided not to. So in some cases, we can see that helping. But we can also see that Facebook might, for instance, create filter bubbles where you only see the kinds of information that you want to see because they know that you will click on it, and they're optimizing for clicks. And likewise with YouTube, you see one conspiracy theory on YouTube, you click on it, it shows you another even more extreme conspiracy theory, because that's what you're most likely going to click on, and then you become, you live in a filter bubble, and you become less open to other people's opinions. So I can see it go both ways, and it's up to us and companies that use that to make sure it has the right impact.
How do you build trust among the public when you're coming out of scandals like the Facebook and Cambridge Analytica scandal, where the numbers show now that a majority of users and consumers expect companies to use technology, to use AI, to manipulate them. So how then do you provide an antidote to that?
There's no silver bullet. I think trust is something that's incredibly important. At Salesforce, for instance, we have a list of values that run through our company, and trust is our #1 value. That was especially important 18 years ago when we were one of the first cloud providers in the world for software as a service. And of course, people back then were thinking, what? I would never put my secret sales data into the internet, which is this like weird new thing. And so trust is incredibly important. It's very easily lost. And you have to be very transparent with your users. How do you use their data? Who owns their data? Who has access to your own personal private data? And the more of such data you have, the higher your responsibility is. And the more you have to really reflect when you messed up and really say, this is what went wrong, this is how we're fixing it. So trust is very important. There's no silver bullet. It really depends on your industry.
Do you believe in industry controlling itself, policing itself, or do you tend to be from the camp where you think that more oversight and regulation is needed to make sure that this technology stays ethical?
It's a good question. Should we regulate AI?
Yeah.
I think it doesn't make sense to regulate AI in the abstract and in general. AI is not useful and used in isolation. It's always AI plus X. What are you actually applying it to? Just like it doesn't make sense to regulate all of computers, because you can use a computer for illegal activities or to just share public information, be a news website or something like that. And so when it comes to specific applications, I actually do think we need to regulate AI. When AI is applied to transportation and self-driving cars, we shouldn't let self-driving cars drive willy-nilly on our roads. Only if they have certain amounts of accuracy, they've gone through certain tests and so on, should they be allowed on public roads. In medicine, you already have a lot of regulatory bodies. In the US, you have the Food and Drug Administration, FDA. So before you can let an AI loose on a bunch of people and make potentially important medical decisions, you have to make sure it's accurate enough to be able to trust it. And then eventually, I think there will be interesting ethical questions. Even if you do everything right and you have regulated and you show statistically speaking, for instance, a self-driving car is safer than people. But safer doesn't mean 100% safe. If it's 100% safe, you don't need AI. You just have if statements. If this, then do that. But in the real world is fuzzy and noisy, and you may eventually end up in scenarios where one algorithm kills 100 people in self-driving cars, but statistically speaking, 5,000 would have died in the same amount of miles or kilometers driven, but now it's one algorithm that's responsible for it versus like 5,000 people who were texting on their phone at the same time. So interesting and important ethical questions will come up in the future, but we should regulate.
How do you answer that? I mean, because think about the driverless car project. I think it was with Uber, and there was one fatality, and then they shut the project down, right?
That's right.
So the reaction to that, when it's not necessarily a human causal factor, is to just go cold turkey. Do you see that continuing to be the case? I mean, what you're asking us is to treat AI as if we were treating it as a person.
I'm not sure we should go all the way there. I don't think we need to give it citizenship and things like that. That's more of a marketing stunt.
Yeah, okay, but to trust the technology as much as we would trust another human being.
To some degree, yeah. And of course, like I already know Google is looking at all my emails and gives me better advertisement, but no human is actually looking at my emails. And that can be okay too, but it needs to be more transparent about how your data is actually being used.
Okay. Any questions? We got time for one question. Yes, right here.
Your microphone
She's going to
is
give you a
coming.
microphone right there.
We both took your CS224 course online. Thank you for that. So now we're both working for a startup in Bremen on NLP tasks, and it's always a huge struggle to find a data set in German. We're always looking for something like squad in German. So it was really, this is a dream come true. What would Richard Socher do to do NLP tasks in German and make things as good as if you had a English squad?
Thank you. Thanks for having taken my class. It's actually really fascinating, and it's something that I think is incredibly important these days, is to think when you're rolling out AI is also how do you actually educate people, not just to use it, but also what happens for certain kinds of jobs as the nature of those jobs changes significantly. So at Salesforce we have Trailhead, for instance, and my next version of that class will be on Trailhead with videos and prepared for an online audience too, because you can reach a lot more people that way. To answer your question, I think Germany could actually publish more large German data sets to actually help natural language understanding in German as well, and I hope universities and maybe even companies would do that.
Okay. Well, we're out of time. Are you going to go over? Are you going to have any time for the questions corner later today? Are you going to be there to answer questions? It's not in your plan. I don't know.
I don't think so.
Okay.
Sorry.
Anyway. All right. Well, Richard, thank you very much. Let's give Richard Socher
Thank
one
you.
round of applause.
Thanks for coming, everybody.
Thank you, Richard. And thanks for making the changes so quickly. I appreciate it. Thank you.